Hey guys, it's Joe here. I make tech interview videos on YouTube, and today's problem is top K frequent elements on Leetcode. Alright guys, it's been a while, so I haven't uploaded for like 2 weeks, but we're getting back into the grind, more Leetcode. So here we go, top K frequent elements. So given a non-empty array of integers, return the K most frequent elements. So we can see here that 1 appears 3 times, 2 appears 2 times, and 3 appears 1 time. And the top K, which in this case is 2, K most frequent is 1 and 2. And that's why the output here is 1 and 2. And same thing here. So we can see also that. And here also it says that we need to beat n log n runtime for these for our algorithm. So one way to think about this is that if we want to beat this algorithm, we need to have something that kind of is close to this, or use some data structure or algorithm that achieves this kind of complexity. So we have things like sorting, we have things like also heaps. And if we think about it, a heap would actually work perfectly here, because what does a heap do? We can pull off of the heap for, let's say, the most smallest number or the most or the largest number pretty quickly. And we can see that, you know, if we have a heap here dot pull, this will have a runtime of log n, where n is respective to the heap size. And if we need to find the K top or K most frequent elements, we can have a complexity which is K times log n, where we perform log n K times from the heap. And we can also see here that instead of having, like, you know, the K most smallest elements or the K largest elements, we want the K most frequent elements. So we can just modify our heap to make sure that we can sort off of the most frequent elements that come in. So let's take an example here. You know, in this case, we would have our heap here, and inside our heap, we would have some int array that would have 1 mapped to 3 because it has a frequency of 3. And we're just taking a key and mapping it to some frequency. And that's what this is. And then same thing here, 2 mapped to 2. And then we have 3 mapped to 1. And here when we call poll, we'll essentially get this first one, then this second one, because it's going to be sorting off of these frequency numbers. And that's about it, guys. So like, we'll be able to achieve this runtime, which beats n log n. So let's get to it. And I'll just keep that here just for reference. And here we're going to be using a priority queue, which is the way that Java implements its heap data structure. And we'll call it a heap, priority queue. And here we want to give it a comparator, and we want it to compare the second elements, which is going to be the frequencies. And yep, that's it. And then we'll also have a map here, integer to integer. Map is going to be equal to a hash map. And what we want to do is just go through and give the frequencies here, or get the frequencies in the map. So we'll go through, get each number, and we'll say map.put of the number, and then map.get or default to, so get of the number or default to 0, and just add 1. And then we want to go through the each key in map.key set, and here we want to say to put everything into the heap. So heap.add the, and we want a new integer array here. And we want to add the key, and we also want to give it the frequency that we have from the map, so map.get of that key. And so see here, so we have, yeah, so it's going to be the key here, and then the frequency for that key. And then we want to now get our answer, which is going to be a size of k. And here we'll say just go through the heap, and we'll do this k times. So integer I is equal to 0 while I is less than k, I plus plus. And we'll say that answer at I is going to be equal to heap dot poll at 0, which is going to be the key in this heap. And then we just return the answer. And I think that should be it, guys. Hopefully no small issues here. And yeah, that's it. So that's it, guys. Please like, comment, subscribe. Let me know if you want more stuff like this. And that'll be it.